This question is an algebra question. We are given a quadratic equation and you're asked to solve it, i.e. find the values of x that fit this and make it work, make it equal to naught. Now the biggest clue here is give your answers correct to 2 decimal places. This is a very clear sign that all they want you to do is use the minus b formula. So our values of a, b and c refer to the coefficients of the x squared, of the x term, and the number on the end. So a is 1, b is 2, c is minus 4. And I substitute those numbers into this formula. So minus b plus or minus the square root of b squared minus 4ac. Notice with c that minus is part of that number, all divided, and one of the key mistakes people make is they don't put that line across everything. They tend to put it just over the square root, or under the square root, sorry. You have this line across underneath everything, all over 2a. So then when you tidy that up, you can use the calculator to do that as a job. We get minus 2 plus or minus the square root of 20, all divided by 2, and that root 20 can be tidied up a bit more. And it should be clear that divide by 2 can be acted upon both parts on the numerator, and we get minus 1 plus root 5, and we get minus 1 minus root 5. And because it asks for 2 decimal places, 1.24 and minus 3.24 are the two solutions correct to 2 decimal places. For part B, there are 2 methods really to look at this solution. So we're looking for the turning point of the function. So it's worth us just appreciating for our first method the idea of a quadratic function, a positive quadratic function. We've found that in terms of the x-axis it's crossing at minus 3.24 and positive 1.24, and we want to find that minimum value, that turning point there. So that's roughly where the y-axis is going to be. That's 1.24, that's minus 3.24. So you should know that a quadratic curve is symmetrical. So the turning point is going to be, in terms of its x-coordinates, is going to be halfway in between the 2 roots. So if I just find out an average of my 2 roots, I'll get my x value. So if I add the 2 roots together and divide by 2, I will find that the answer to that is minus 1. And to find the y value, all I need to do is put that value into the function. So minus 1 all squared plus 2 lots of minus 1 minus 4, we end up with minus 5. So our turning point is minus 1 minus 5, which is what it was asking for. This to me is the more intuitive way of looking at it, but no doubt the textbooks would probably look at doing a more sort of algebraic approach and maybe using calculus. So for any turning point, and for something more complicated than a quadratic, if you were doing a cubic, you would have to do this following method. We can take our function and differentiate it. So the first derivative of the function will be 2x plus 2, and we're looking for the solutions when that first derivative is equal to 0. So the turning points occur when your dy by dx, your f dashed of x, is equal to 0. So if I find the solution of 2x plus 2 equals 0, I end up with an answer also of minus 1. And again, I then go and substitute that back into the function, the original function, not the derivative function, but the original function. And as I had done here, go through that process, and I would get indeed the same answer. So my point again is -1, -5. Two different methods, both will take about the same amount of time. You're either differentiating and equating your derivative to naught and solving that to get your x value, or because it's quadratic, because it's symmetrical, because it's going to be halfway in between the two roots, we just find out the average by adding them together and dividing by 2. So we have 3 pieces of information from part A and part B. We have the where it's crossing the x-axis, the roots from part A, and we have a turning point from part B. Now, you could have left B blank. They've still told you -1, -5 is the turning point. So even if you did have problems with B, you still can carry on with C. And a fourth point that we should be able to realise very quickly, just by looking at the function, it has a -4 on the end there, okay, and we should all know that that value on the end, that constant on the end, is where it crosses the y-axis. So I know that it crosses at -4 because -4 is the constant, the term independent of x that's in the function. So we have the turning point, and lastly we have the intersection points with the x-axis that we gained in part A. Now it's purely a matter of, and it only says sketch, so it doesn't have to be accurate. You're not needing to work out any other points, and you'd expect it just to come up with an appropriate curve that looks reasonable. And one other thing I should mention is, because a quadratic is symmetrical, we're going to have this sort of U-shape sort of curve, and because it's symmetrical about that turning point, we have a situation where this value here, this point here, can be reflected and replicated on the other side. So as an additional point, we have -2, -4. So there's 5 points there. We can do a fairly decent curve, as long as it's a half decent job. Make sure you use pencil, and don't use a ruler. It's not join the dots. It's a smooth curve as you can do with a pencil on the sheet. Moving on to part D, you're needing to understand transformations of graphs, and here we are taking away 2 from the function. This take away 2 as just a number on the end, a constant. This is a vertical movement up or down. So if we're taking away 2 from everything, everything is being moved down 2 places. So we have every single point is 2 units below and then you just draw your same graph going through those points. For the last bit, function h, where we have this -2 appearing within inside the function, so the function of x -2, well, this creates a horizontal movement. It's sort of counterintuitive. -2 is a movement to the left, sorry, movement to the right. Okay, we're moving in movement to the right for a negative number. So even though you think it's positive going in that direction, okay, it's actually this negative number makes a movement to the right. So my blue curve, every single point on my blue curve is going to move 2 points to the right. So we have a series of points. 1, 2, and our curve will look something like that.